At the end of the first meeting last week, I told you that we would, during this session, show you how to use a camera of the type that was used towards the end of the 19th century and at the beginning of the 20th century. Indeed, this type of camera, surprisingly enough, continues to be used today. But this one is about 100 years old, about 100 years old, 1920, something like that. And I'm sure that you'll look at this and you'll say to yourselves, well, actually, how does this work as a camera? How can you use this as a camera? I could show you it's beautifully made with brass fittings and fixtures. It has a little pendulum, that's a plumb line to make sure it's vertical. At the top here, it has a beautiful little spirit level, which you could see the little T there with liquid inside it, and that enables you to set it up and make sure it's absolutely horizontal, etc. I, of course, in today's demonstration will not be making use of these devices to level out the camera, but I hope, above all, to take a good photograph with it. So I've shown you a little bit about it, and I'm sure you're quite puzzled to know how on earth one can take a photograph with this. Well, obviously, we have to unfold it, so to speak. And the way we do this is, first of all, you'll notice there are various brass screws on there, which we can operate with our fingers. And by unscrewing them, we can enable to free up the mechanism to open the camera. So that's what I'm going to do now. So we start off here by unscrewing these two here. We then, there is also a little catch here, which we have to undo there. There we are, just undone that catch there. And having undone those two screws, released the catch, we're now able to open up the camera. So I'm now using the screws here to make it secure in this position. We now have a right angle. You recognize inside, this is the bellows. This is a leather bellows, and of course the purpose of it is stretchable, it can move backwards and forwards, and it keeps the light out. But still something is not quite right, of course, because we now have to open the camera up from the front. We've opened it up from the back. We now turn two further screws, and there we are, bingo. It's now beginning to look a little bit like a camera. So now what we have to do, you'll have to excuse me, I'm going to be concentrating. I'm looking at what I'm doing rather than looking at the camera, because this has to be done carefully. We now have to set up the camera by tightening these screws here. And I've done that there. And now what we're having to do, I'm just going to set it up in a vertical position. So there's one further lever which I have to get to here. Excuse me, I'm just going to fiddle around a tiny little bit, just a tiny bit of fiddling. There we are, I've just got that lever in. It's that lever here. It's that lever here. This locks it to make sure that it's in the vertical position. And there's one on each side. Actually, the one on each side, the one on the other side is broken, but that doesn't matter. We'll certainly be using this one to set it up correctly. So there it is, that's in position now. And we will release this a little bit here, there we are. Sorry, I'm just twiddling a little bit. Ooh, I've done it up incredibly tightly. So we have just undone it there. And now we're just released that. So we've now hopefully got the camera set up in order to take photographs. But I'm sure you'll have noticed there are certain other things which are missing. And of course, the most important is obviously the lens. So I have a lens here, which I'm going to now screw into the camera. This, by the way, is a lens which was used for taking photographs of land from above. They used aeroplanes for taking map making, etc. And it's an 8.5-inch focal length lens, and it's not the original lens for this camera. This whole front plate, I actually made it myself because I bought the camera, it was in bits and pieces, and I've sort of more or less stuck it together. Now, one interesting thing, by the way, I should show you about this lens, and before I actually set it off, is that the lens has inside something which is called a diaphragm. And if you don't mind, I'm going to just operate. Actually, I've got another one of these lenses here, and I think this one's just a little easier. Yes, I'm going to hold this up much closer to you and operate the diaphragm. I don't know whether you can see it, but I'm actually opening it now and closing it now. Opening and closing. And in photography, the amount of light that goes through the lens is absolutely crucial. And brilliant techniques have been devised for monitoring or adjusting the amount of light. And one of these is the mechanically operated diaphragm, which I've just been showing you. Now, I am going to have the lens open in the maximal position to allow maximal amount of light through. And the next thing which we have to say, well, how do we take a photograph? You know, where is our light sensitive device which we use? Well, in this particular case, we are using still chemical techniques. As I explained to you last week, the chemical that's used principally in black and white photography is silver bromide. And so the chemists have enabled this to be affixed to various surfaces in order that it can react with the light and then produce a photograph. Now, initially, the light-sensitive material was present on metal plates, and it was on metals that, in fact, they used to expose them to iodine vapor. All sorts of remarkable effects were achieved. Chemicals were used, and in conjunction with metals to achieve photographic results. Now, I don't have any metal plates to show you, but I do have a glass plate. And here you see in this darkened paper, because that's how they used to arrive. So to take a photograph, one photograph, this is not, by the way, the right size for this camera, but this is a glass photographic plate. It's a sheet of glass, and it's coated with an emulsion here, a gelatin coating containing silver bromide. This obviously has been exposed to light, so it's useless. But that is how people used to, originally, that was towards the end of the 19th century, that's how photographs were made on glass plates. But this is obviously cumbersome, it's brittle. So with the development of polymers, polymer chemistry, towards the end of the 19th century, people started inventing a plastic backing. And the plastic backing is what I've got here. This is a celluloid film. They were initially made of nitrocellulose. That was too inflammable, so and a very dangerous fire hazard. They then modified it, and it's made out of other polymers. I'm afraid I can't tell you what they are. But this is an example then of a plastic film which is glossy on one side and which is coated with the silver-bearing emulsion on the gelatin-coated silver-bearing emulsion on the other side. So that is what constitutes the film in or used to constitute in black and white photography, using the chemical technique, the chemical means. And I wanted to tell you that when a photograph was taken with a piece of film like this, we would traditionally end up with a negative. So when this is developed, we'll end up with something like this. And this is just an example of, you can see it, you can see through it, and you can see some sort of image. It's not important to note what the image is, but the point is it has a completely different appearance. It's the reverse of what you would normally see. That's why it's called a negative. And the photographic print was made using a negative and paper. Now, that's something I'm going to show you next week. But today, I'm focusing on taking a photograph with this camera. Well, having showed you, first of all, how the light-sensitive material is here, I'm then going to say, well, how do you put it into the camera? What sort of device do we have for putting this in? Well, I'll show you. What we have is something which is called a plate holder. Now, this is a plate holder which is used for this camera here. And the method of operation is as follows. You have a plate holder like that, and you pull this is the gate which opens, gives access to the photographic emulsion inside, and then you close it like that. So in order to set this up this is totally dark inside. No light can access it when these gates are closed. So if I now slide this open, you see, and I want to put a film inside here, or one of these, for instance, one of these negatives, I have to do this in pitch blackness. I have to take it out of my darkened box, my box with black paper, have to slide it in by feeling and locate it, and then close the film up. Now, today, I am not going to be using plastic film, I'm going to be using positive paper. Now this is this is the paper I'm going to be using. Notice it's got this pink color here. And this positive paper is remarkable because it will give you a print straight away. The photograph which will come out of this will be as you see it. It will not be a negative photograph, it will be a positive. So, and this type of paper, by the way, is used in schools. You may have already used it with pinhole cameras. You can take fantastic images using this type of paper. So that's the type of paper I'm going to be using in this film holder here. Now I have to tell you that to load the paper up, all you have to do is you have to slit, you put it in here like this, you see, you slide it in like that, and then it goes right up to the top, then you close the bottom off like that, and then you slide your gate to close it like that. So excuse me, I'm just looking at this, I'm just showing you very, very briefly a crude way of putting it in one of these teeth. So there it goes, you now slide it down like that, and now our sheet of photosensitive paper is in there. Now the good news I have to tell you is that this paper is orthochromatic. What that means is, by the way, let me show you the box of this paper. This is how it comes. It's a Harman direct positive paper made by Ilford, and it's specially manufactured for teaching purposes, so that teachers can skip out the negative state. You get a result straight away in one go. So just showing you this. This is available, and if any of you want to come and learn how to use it, take photos with me with the camera, more than welcome. I'd be always delighted to help. So we're going to use a positive paper. Now the other advantage of this paper is that it's not sensitive to red light. So that means that during today's demonstration, you'll be able to see everything happening in the darkened room. Because I have red safe lights here. So it'll be a bit murky, but hopefully you'll be able to see the thing go. Now, how do we therefore, so I've got my plate here. This is my plate holder here. I have now got, I have put in a sheet of this photosensitive paper in here. How do we attach this to the camera? Well, I'll show you. At the back of a camera, this camera, there is something called a focusing screen. Now, regrettably, this focusing screen has cracked, and I've had to stick a piece of sellotape over it, but essentially it's a piece of ground glass, and what you do is you focus the image that you're looking at onto this ground glass, which is what I'll shortly be doing. So that's your focusing screen. But the next thing you say is, well, how do you put the film in? Well, the very clever thing about this focusing screen is it is spring loaded. So what you can do to put your film in, you pull this back like this. There are a couple of leaf springs there, and I'll show it to you close up. The leaf springs then, and then you can just push it in, pop it in like that, and then to make the exposure, you take out your cover, the plate which covers the gate which cuts off the lights to take the picture. But then I hear you saying, but what if you've got the lens here? Then it's not going to be much good, because light will start falling on this straight away. And I have the answer for that as well. For that purpose, we normally use shutters on cameras. Now, last week, I demonstrated for you the shutter on this camera here, and it's a beautiful thing. Remember, I pulled this toggle and we made a nice click on it. You cock it like that, and then you press this, and there it goes, and it goes off like that. There is no such shutter device on this, you see. This is a simple camera. And the way I am going to do today, I'm going to actually have no shutter or no cover at all for this. I'm going to simply set up, I'm going to be taking a portrait of Oscar, who's helping me today, using this camera, but I'll be setting it all up only with red light on. So I'll be able to make my the lens, once we get ready to take the photo, there'll be red lights on, and then I will make the exposure. But the next question is, how am I going to make the exposure? Well, the Victorians didn't have electric lighting. They did have carbon arcs, mind you, which were very bright but very unpredictable, etc. But I'm going to use one of my favorite techniques, and this is the technique which was, of course, was used by the Victorians, and that is to use a magnesium flash powder. And magnesium, as you all know, burns with an extremely bright white flame. It gives off a huge amount of ultraviolet light, and the Victorians exploited magnesium flash powder for photography. Initially, they were simply powders which were ignited, which is what I'm going to do today, but later on they invented magnesium flash bulbs, and once you used it, you threw it away and you took another one. So what I have to show you here, I have a little flask, a tiny conical flask. Have a close-up look at it. Oscar will bring it right up to the camera for you, and you can see who on earth could imagine a conical flask 10 centimeters tube. What on earth would you want to use those for in a laboratory? Well, I'll tell you, apart from the use I have today invented for this, which is to store my magnesium flash powder, it is in research laboratories and in university laboratories. When you make a small amount of a compound, and sometimes they make tiny amounts of compounds, far smaller than this, but if you're making amounts of compound of 1 to 2 grams, then you put it in a flask like this, and it has, you see the ground glass joint there where you put a ground glass stopper. I'm today obviously not doing that because I've just got some flash powder in there. Now, so how am I going to set off the flash powder, and how am I going to use it? I'm going to pour it into this lid here, which is a bit of, obviously a jam jar lid, which I've burnt out a little bit and done a few trials with it. And I'm going to put it on this bird feeding stand, which I have here. And I'm going to then set fire to it with a splint. Thank you, Oscar. Good to show. This is an improvised splint which I have here. I don't have any laboratory splints here, so I've joined 3 long matches together with a bit of tape. Now, I do have to tell you that it's not easy to set this on fire, and I may have a few attempts, but I just wanted to show you this is an improvised wooden splint which I've made, with which I shall be setting the magnesium on fire. So what I'm going to do now, I'm going to put my lid on here. I'm going to pour our flash powder onto it, and there, so you can see closely. So there goes our magnesium flash powder. By the way, I'll tell you exactly what it is. It's 1 gram of magnesium powder and 0.3 of a gram of potassium nitrate. Now, in today's demonstration, of course, there is no particular science involved. I haven't measured the light. I haven't done quantitative calculations, because all of today's computerized cameras, such as the one this is being filmed on, have everything done to a phenomenally high standard of science. Today, it's a little bit of hit and miss. So I'm going to do my best to get a result. We've had a few trials, not very successful, most of them, but I'm hoping that we'll be able to get a result for you. Now, I'm going to now move my bird seed stand into a position which we have carefully marked on the floor here, and I will explain to you what's going to happen in the next few minutes. During the next few minutes, I'm just going to put my splint, put my flask down here with the splint. During the next few minutes, what's going to happen is this. Oscar, who is behind the camera at the moment, will sit down on this chair. He will then move into a predetermined position where we've been practicing this. I will then place the camera onto this stand. By the way, this is a very, very important tripod. It's obviously called a tripod, but it's a Gandolfi. If you know anything about good quality equipment, this Gandolfi is the Rolls-Royce of wooden tripods for photography, and I happen to be very lucky to have one. It's a very, very heavy-duty stand, as I'm sure you can see. So I'm going to place the camera on there, then I'm going to focus, I'm going to ask Oscar to sit down here. I'm going to focus the camera on Oscar, and then I shall undertake a series of procedures during which I shall place this. I've actually put this in here at the moment, but I can't have it here at the moment because I have to focus and use my focusing screen there. So Oscar, if you're ready, let's now exchange positions. I will now start setting up the camera, and hopefully you can see something that we've been preparing for you. So I will be maneuvering around, I will be turning my back to you, I'll be doing all sorts of things, but above all, now Oscar, is that the position the chair was in? I think it was a bit more forward. If you could just take great care. As I said, everything has been approximate. So this is the detail then. This is the camera. There's the camera with the film. I'm going to focus that shortly. Here's going to be our source of light. So you will see a bright flash going off at one stage. And there is the subject, which is Oscar, whose portrait I'm going to take. Now, one thing which you can't see, which is behind me, and that's a white umbrella. Photographers frequently use white surfaces to reflect the light. This is a point source here. It'll be a very bright flash. The screen will go white, but I'm sure it'll be fine. And also, I have to tell you that when this bright flash goes off, a small puff of magnesium oxide smoke will go into the room. Now, this puff of magnesium oxide smoke will disperse itself, and as I have explained before, I do have an extractor fan, a very powerful extractor fan, especially which I built into this cellar when I moved here some years ago. So the smoke will disperse. It's not actually that particularly dangerous in any case. So I am now going to switch off the lights in here, but before I do so, I'm going to switch on another light which I have, which is the light I'm going to be using for focusing onto Oscar. So this is obviously, the Victorians wouldn't have had this, but the point is we have to improvise a little bit. So I am now going to switch off the main light. I'm now going to switch off the main light. So, and now, if I now turn off this light, what you're going to see is a pale red glow. There you are. I don't know what you can see. I hope you can see something, but even if you can see nothing, don't worry. I can see plenty, and we'll hopefully get a good result. So I'm just going to turn the light back on now. Then I'm going to focus on Oscar. Now, in order to focus on Oscar, I have to be able to see what's inside here, but I can't see because it's so damn bright, and it's outdoors when you're doing this. The sun is shining or whatever. So what people used to do, they used to use large black cloths. Now, unfortunately, I couldn't find my black cloth today, so I found one of my wife's best black coats, and I'm going to use that to hide the light from this. But please don't tell her anyone, because otherwise I'll get into serious trouble. So I'm now going to use one of my wife's top black coats you see here, and I'm going to use this in order to focus on Oscar, to make sure that Oscar is sharp. So if you just carry on looking, Oscar, it's not easy at all doing this focusing, I have to tell you. By the way, to do focusing, you have the aperture open at a maximum extent, so the maximum amount of light is going in. I'm pretty certain that's as good as I can get. It's not let me just approximately there. Okay, that's it. So we've now focused it. Now, having focused it, we do the next stop, which is to stop it down a little bit. Now, the purpose of this is to make less light go in, because otherwise the photograph would come out too light. But there's another important reason, and that's to give us an increased depth of focus. The more the lens is stopped down, the less light that's going through it, the sharper the image you get. Sorry, I just checked that that's now done. So we're now almost ready to go. Oscar has lit a candle for me down there. There's a burning candle. I've got my splint here. We've got the magnesium there. I'm now going to turn off the main light, the focusing light, so you will have to get used to seeing probably very little indeed. I'm hoping, I now have to, sorry, before I do that, silly Billy, I forgot to put my film in, you see. Here it is, of course. Not much point in having a focusing screen, but no film. So I'm going to now put this in behind the camera, and the trick is not to disturb the camera at all, because if I move the camera, then obviously the thing will go out of focus. So, having now put my film in, I'm now going to open the gate to allow, so light is now going into the camera, and it's falling onto the back of the film. But the light is red, so the film is completely unaffected, and the burning candle does very, very little indeed. So Oscar, if I will now ask you to look at that, I am now going to try and set this on fire. Now, I do have to tell you, it's very, very temperamental. So sometimes it goes, sometimes not. But let's hope we can make a satisfactory exposure. So there should be a bright flash of magnesium going off, if we're lucky. Et voilà. So that was it, you see. We have now made our exposure. We have now a huge amount of light, as I'm sure you'll agree, has fallen upon Oscar. And I'm now going to, of course on me, and of course on the thing. Now Oscar, if we could turn on the fume cover at this stage, thank you very much indeed. So Oscar, so you'll hear a whirring sound. Now that's obvious because we've got the extractor on now. And what I'm going to do now, I'm now going to, I don't have any tongs here, Oscar, you know, the photographic tongs, maybe they're in the sink down there. I'm now going to keep fingers crossed and hopefully show you an image coming out. You might find some tongs, if not I'll just use my fingers because we've got to get it. Ah, brilliant. Thank you very much indeed. We must have tongs. Now I don't know what you can see, but Oscar will manipulate the camera. So here is our exposed photographic paper, but we don't know whether there is an image on it yet. We can't see because we have to put it into developer. Now, I told you a little bit last week about developers. They're reducing agents and they bring out the silver ions which are converted into silver atoms, but I'm not going to talk about the chemistry. I'm just too nervous and I hope we're going to get a result. So I'm popping it into the developer now, and I'm gently moving it around, and Oscar may be able to bring the camera closer. I don't know what the possibilities are. Hopefully we shall shortly see an image developing. At the moment I can see, something is happening. Something is happening. I can see a very, very slight darkening of the paper, but how much it's going to darken or how much the image will come out will remain to be seen. Now, it's going to be a little tricky. I don't know whether I can see, actually, you know, I can't see any darkening at the moment. Let's just carry on hoping. I thought I saw, in fact, I was looking at a shadow. Now, this can take up to a couple of minutes, and I also can tell you, it's absolutely possible that we'll get absolutely no result because we have had a few trials today, and the trials have not been very successful. I'm continuing to hope, but the honest truth is, this doesn't seem to be delivering a result at the moment. In fact, I can tell you it's delivering absolutely no result at all. So what I'm going to do now is I'm going to ask Oscar to turn off the camera, you see. And what we'll do is, I don't know why it hasn't worked. I have had problems. I think this paper is old. There are some issues involved, but we will attempt to take another photo and we'll return to you in 5 minutes. So just a couple. So here we are, it's our 5th attempt now, and hope is not very high, but we just carry on plugging away till we get a result. So I've put the exposed paper into the developer, and hopefully we'll see an image appearing. And yes, I'm pleased to report that we do have light at the end of the tunnel. There is a faint image appearing, and very shortly I will bring this up to you. I will ask Oscar to bring the camera up closer. I'll ask Oscar to bring the camera up closer so that you can see. It's not particularly brilliant, but I'm hoping you can at least see something is developing. There's definitely an image, and the young lad is there. And so we'll leave it now. And this is the reason why I'm showing you this process is because this is the great thrill of photography. See, when you develop your own photographic prints, the sheer delight of seeing an image come out in the darkroom, this is one of the greatest pleasures and delights of photography the old-fashioned way. And I can reassure you that for the number of attempts we have taken to make this print come out, and for the huge effort that's gone into it, this is not one that I'm going to be deleting in a hurry. So we're just going to carry on. I'm just going to now allow the image to go a little bit further, and then I'm then going to put it into an acid stop bath. Now, developers are alkaline. They contain, as I told you, hydroquinone, which is 1,4-dihydroxybenzene. They are reducing agents, and they function best in alkaline solution. The way, if I were now to turn the lights on, the whole thing would go black, obviously, because it would be exposed. The light would be it would go white. Should I say? It would go white. The whole thing would get exposed. So what we do is we kill off the developing action by putting it into a bath of dilute acetic acid. It's about 1%. It's a very, very weakly acidic solution. At this stage, that means that the print will now no longer get any lighter. It won't develop any further. And now we put it into the final dish, which is the fixer. Now, Oscar, it's now in the fixer, so can I ask you to turn the lights on, please, while we have a few concluding comments. And what I'm going to tell you is this. First thing is, could you turn on as you see there's a little bit of smoke in here, that's no problem at all. Oscar will now turn on the fume cupboard, and then we'll be able to have a look at this image. It's come out, Oscar's come out extremely well, if I may say so. And Oscar, if you can bring the camera up, and then we can have a closer look, and then I'll show you the one which we made earlier on, which I think actually was just a tad sharper maybe. So that's the image which we've made just now. It's a success. It's not brilliant, but it's a result, and it certainly showed the thing in action. And if you just hang on a second, I will show you the image which we made earlier. So there you see, I'm just letting this drip off. I'm going to touch it with my fingers, by the way. This is not at all corrosive or dangerous. So this is sodium thiosulfate solution, by the way. There you see another image which I had made successfully earlier. Now, how did I go about achieving this result, and why did I get a result in the end? Well, I tested the paper. It has turned out that some of the paper in this box which I showed you earlier, Oscar, if we could just now zoom in for the final shot. Thank you very much, because I'm going to be showing my final thing there, final photograph there. The way I did it was I tested the paper by cutting a little bit off and putting it into the developer. And this one, you see, can you see that? That's completely black. Now that's unexposed paper, and so by testing it, I was able to have good confidence that this one would work. Now at the same time, I tested a few others, and they had gone white. Now, which means that they had been exposed to light. Now, I'm sure you know that this effect of photographic paper or photographic materials being exposed when they are contained in a closed dark envelope led to one of the greatest discoveries in the history of science. And I'm sure you know what that was. That, of course, was radioactivity. It was the great French physicist Henri Becquerel, 1896, who was also desperately interested in photography. As I told you, photography was of great interest from both the creative and the scientific point of view. Becquerel had a number of photographic glass plates which became darkened, even though they were contained in black paper like this, they were, etc. And the reason why, of course, is because they were being exposed to alpha radiation from a thorium isotope, which was present in some of the mineral parts of his mineral collection, and that led him to recognize that there was an invisible radiation coming off from this particular rock. And that, of course, the discovery of radioactivity, one of the great triumphs of modern science. And to finish off with, I wanted to ask you a question. Do you think, having seen this equipment in action and having achieved the results, do you think it might be possible to take a selfie with this camera, with this paper, with this, etc.? Well, I'm sure you will agree it's not something which is easy, but I have to tell you something. I have actually managed to do this, and I wanted to show you the remarkable result which I achieved a few years ago. And here is my photograph of myself. It's a selfie which I made about 10 years ago at the back of room C1. Now, how do you think on earth I was able to set this all up in room C1 and expose it and then develop it without the red lights and all the rest of it? Well, I have two things to tell you. The first one is that on my lens, on top of my lens, I had placed a lens cap like this. So in other words, even with the lights on in the room, there was still no light. So to make the exposure, I just simply took this off. Now, the whole of room C1 was black because it was done on a late October evening, so it was pitch dark. And how do you think I set off my magnesium powder? Well, this gives you the clue. You can see that stick which I am holding there. It is with that stick that I made the exposure.